Hey guys, and welcome back. My name is Miss Danielson, and today we're looking at transformations. More specifically, we're focusing on reflections today. Now, whether you're in year 7 and this is fairly new to you, or you're in year 9 and you're preparing for your checkpoint exams, or you're in year 10 or 11 and preparing for your GCSEs, these topics really don't change much throughout Key Stage 3 and 4. So hopefully this lesson will give you a good strong base so that you can move forward with confidence. Let's get into it. First of all, today we're just going to focus on reflecting in horizontal, vertical, or diagonal lines. Now we call these lines of symmetry, or mirror lines, or lines of reflection. You need to be familiar with the correct vocabulary in order to access full marks on these types of questions. Now, you will only ever be asked to reflect in perfectly horizontal, vertical, or diagonal lines. If you're not familiar with the equations of horizontal, vertical, or sloping lines, you may want to check out my video with that title. I'll make sure I post it down in the description box for you below. I would imagine most of you are pretty familiar with the basics. A transformation is a way of making an image look slightly different. A reflection transforms an image by flipping it over the line of symmetry, or the mirror line, or the line of reflection. Now, you might be used to calling it a flip, but please don't use that vocabulary on your exams. It's called a reflection, not a flip. That's going to lose you marks if you don't use the right words. So for example, here I've got a triangle, and I've got a mirror line, which is a horizontal line. Horizontal means side to side. Make a note of that if you need to. Horizontal lines always have the formula y equals some constant. That is, y equals some number. For example, if I set up my axes here, you'll see that this horizontal line crosses the y-axis at the number 2. And since it's a perfectly horizontal line, every point along that line is lined up with the 2 on the y-axis, which is why this line has the equation y equals 2. Again, check out my video on horizontal, vertical, and sloping lines if you need more of an explanation about that. So to use the correct vocabulary, you might be asked to reflect this triangle, or this image, in the line y equals 2. In order to do that, we need to follow the rule. Each point on the image will maintain the same perpendicular distance from the mirror line, but will appear on the opposite side of this line. Now, what I mean by a perpendicular distance is the distance directly towards the line at a 90-degree angle. You see how I've plotted this point here? I've drawn an arrow directly towards the line, and that arrow is forming a 90-degree angle with my mirror line. Now I measure that distance, and it's 1 square above the mirror line. So its reflected image will be 1 square below the mirror line. Same thing with the other coordinates. This point here is 1 square above the mirror line. So I'll reflect it 1 square below the mirror line. And this furthest point up at the top here is 1, 2, 3, 4, 5 squares above the mirror line. So I'll reflect it to be 5 squares below the mirror line. Now take the time to count the distance carefully and plot your points accurately. Now that I've plotted all 3 vertex points of this triangle, I can just go ahead and join those points to draw my triangle, and I'm done. But you might also be asked a different type of question about reflections. Here I can clearly see that B is a reflection of A. So if ever I'm asked to describe a transformation, make sure you use the correct vocabulary. We would not say it's flipped. We would say that B is a reflection of shape A in the line y equals 2. Now it's important, if they give you a set of axes, that you can work out the equation of the mirror line and give that equation. 2 points, 1 mark for saying it's a reflection, 1 mark for saying the line of reflection. Next, let's have a look at a reflection in a vertical line. Reflections over horizontal or vertical lines are a lot easier than sloping lines, as they both only involve counting the number of squares between each vertex point of the image and the line. So in this case, I've got this vertical mirror line, and vertical lines always have the equation x equals some constant. Now we can only work out the equation of a line if we've actually got the axes. So let me draw some axes in here for you. Just as an example here, you can see that this vertical line crosses the x-axis at 3. And since it's perfectly vertical, perfectly straight up and down, every single point along this line is lined up with the 3 on the x-axis. This is the point 30, this is the point 31, 32, 33. Every single coordinate on this line has got an x-coordinate of 3. For that reason, the rule or the equation of this line is x equals 3. So, to use the correct vocabulary, we could be asked to reflect this image in the line x equals 3, in which case we would need to know where the line x equals 3 is, draw that line, and, of course, follow the rules. Look at the distance of each point on the image from the mirror line. Now, this first point's a bit confusing for me. It's on the mirror line. If you're reflecting an image that is on the mirror line, imagine you're looking into the mirror and your face is squashed right against that mirror. Well, then your reflection will be squashed right against that mirror as well. So again, this one first point, which is on the mirror line, will reflect to a point that is also on the mirror line. However, not all points of this triangle are on the mirror line. Let's look at this next point here. This point is 4 squares away from the mirror line, to the right. So our reflection will be 4 squares away from the mirror line on the left. And this top point of our triangle here is also 4 squares away from the mirror line to the right. So I'll reflect it 4 squares away from the mirror line on the left. Now that I've plotted all 3 points, let's join them up and draw the reflected image. Again, using the vocabulary, I can say that image B is a reflection of image A in the line x equals 3. Now, what if there's more than one line of reflection? Here I've got my image, and I've got one vertical line of reflection and one horizontal line of reflection. These types of questions tend to come up a lot more in Key Stage 3 than Key Stage 4, but they're definitely helpful to help us practice our skills and to help us understand symmetry. So first I'll reflect across the vertical line of reflection, and then I've got 2 images, so I'll reflect both of those images across the horizontal line of reflection. Now you've got this pattern, which is very symmetrical. It's got 2 lines of symmetries. Let's now try reflecting this triangle in 2 different lines of reflection. As you can see, I've got one vertical line of reflection here, this blue one, and vertical lines always have the equation x equals some number. As we can see, this blue line crosses the x-axis at 3. So what's the equation of that line then? X equals 3. And my pink horizontal line has the equation y equals some number because it crosses the y-axis at that number. This pink line crosses the y-axis at 4. So the equation of that line is y equals 4. So using the correct vocabulary, they may ask us to reflect the image A in the lines x equals 3 and y equals 4. So it's important that you understand the equations of lines so that you can correctly graph those lines and reflect the image in those defined lines. So reflecting A in the line x equals 3 gives me this triangle. Feel free to hit pause now if you need to make sure you understand the distance of each of the points of image A from the line x equals 3. Now let's reflect both of those triangles in the pink line in the line y equals 4. Now we've got this very symmetrical pattern here with 2 lines of symmetry and 4 separate images. Another more challenging type of reflection is when the mirror line crosses through the shape. So if you've got a happy face like this and the mirror line is crossing through the happy face, we still need to follow the same rule. Each point on the image will remain the same perpendicular distance from the mirror line, but will appear on the opposite side of this line. So when I reflect this happy face in the mirror line, the eyes will end up below the mirror line, but the mouth will reflect up above the mirror line. And the 2 happy faces will overlap each other. Let's try that out with this triangle here. This time I have a horizontal mirror line, which crosses through my shape. This horizontal line crosses the y-axis at 6, so it's the line y equals 6. And to use the correct vocabulary, we're going to be reflecting this triangle in the line y equals 6. So we need to measure the perpendicular distance of each of the vertex points of the triangle from the mirror line. This first point down here is 3 squares below the mirror line. So let's measure 3 squares above the mirror line. That is placing the reflected image on the opposite side of the mirror line. This next point down here is 3 squares below the mirror line as well. So again, we'll place its reflection 3 squares above the mirror line. Now here's where it gets tricky. This third vertex point is 2 squares above the mirror line. So we're going to reflect it 2 squares below the mirror line. Now make sure you kept track of which coordinate points represent our reflected image. That's the black one, the dark blue one, and the pink one. So let's join those up, and there's our reflected image. Next, let's have a look at diagonal reflection. Now, as you can see, I've got a mirror line, which is not vertical or horizontal, but diagonal. Now, that makes it difficult for 2 reasons. First of all, we now know how to find the equations of horizontal and vertical lines. It's always either y equals a number or x equals a number. But in the case of diagonal lines, the y coordinates and x coordinates are constantly changing. However, to make this simpler for you, 99% of the time, the diagonal lines that we reflect across are either the line y equals x or y equals negative x. In this particular case, hopefully you can see that this is an upward sloping diagonal line. As we go across to the right, the line goes upwards. So I would say that this is a positive sloping line. And the equation is y equals x, because if you look closely at the coordinates along this line, the points 0, 0, 1, 1, 2, 2, 3, 3, and so on, the y coordinate is exactly the same as the x coordinate. That makes this equation y equals x. So we're going to reflect this image in the line y equals x. Now on to the second reason why reflecting in a diagonal line is difficult. We've always been saying up until now that we measure the perpendicular distance to the line. But now that's even more important because usually we just count the squares horizontally towards the line or vertically towards the line. But as you can see, if I count the squares horizontally towards the line, that distance doesn't make a 90-degree angle with my mirror line. It makes a 45-degree angle. Same thing as if I count the squares vertically downwards towards the mirror line. That doesn't make a 90-degree angle either. Since this is a diagonal mirror line, I need to count the diagonals towards the line. Otherwise, you're going to get kind of a warped reflection, like the kinds of reflections you might see at a carnival. So here I've got the 90-degree, the perpendicular distance to the line. And to count this distance, I'm counting diagonally through the squares from this upper left corner down to this lower right corner. That's 1 diagonal, 2 diagonals, 3 diagonals, and that's half of a diagonal. So if I've got 3.5 diagonals on one side of the line, I should measure 3.5 diagonals on the other side of the line. It's easiest to start by counting your half, and then that's 1.5, 2.5, and 3.5. So this is the reflection of this point on this image. The next point is directly on the mirror line. And as we saw before, if my image is squashed against the mirror, my reflection is squashed against the mirror. And then my third point is 2 diagonals from the line. So its reflection is 2 diagonals away on the opposite side of the line. Now note the 3 coordinate points that you've plotted now. Let's join those together and see our reflection. Now I know what some of you might be thinking. You might be thinking, this doesn't look like a reflection, it looks like a rotation. It's very easy to confuse diagonal reflections with rotations. So make sure you follow the steps, reflecting each individual coordinate of your image and joining them together in order. Next, we've got another reflection, but this time, hopefully you can see my diagonal mirror line is slightly different. It's sloping downwards. So the equation of this mirror line is y equals negative x. And again, remember, that on both checkpoint and GCSE exams, you're almost always given diagonal lines with the equation either y equals x or y equals negative x. But just to explain quickly why the equation of this line is y equals negative x, have a look at the coordinates. This point here on the line is the point 0, 0. The y value is equal to the x value. However, this point here is the point 1, negative 1. The y value is equal to the same x value, but negative. This next point on the line is the point 2, negative 2. The y value is the same as the x value, but it's negative. So the rule for every point along this line is that the y coordinates are the negative values of the x coordinates. And you might be saying, except for this point here, but there's no such thing as negative 0. So 0, 0 still follows the rule that the y coordinates of every point along this line are equal to the x coordinates, but with a negative sign out front. So to use the correct vocabulary, we're going to reflect this image in the line y equals negative x. And to do that, we'll follow the same rules. We're going to count the diagonal distances from the line. So for this point here, counting those diagonal distances, not the horizontal distance, not the vertical distance, but the diagonal, that's 1, 2 diagonals towards the line. So on the other side of the line, we'll measure 1, 2 diagonals as well. This next point here is on the line, so its distance from the line is 0. Its reflection will also be on the line. Our next point here is 1.5 diagonals. Again, remember with those half diagonals, it's easy to start finishing off that diagonal. So a half diagonal and 1. That's 1.5 diagonals on the opposite side of the line. This next point here is 3.5 diagonals to the line. So I'll count a half and 1.5, 2.5, 3.5. That's 3.5 diagonals on the other side of the line. Which point is missing now? This point up here. And that is 3.5, so I reflected it 3.5. Feel free to take a moment and pause to check that you understand that and copy that down for yourself. Now that you see those points, make sure you connect them together in order, and you see our pentagon has been reflected in that diagonal line. It may look like it's been rotated, but if you look at the corresponding points, you'll see that they are the same distance away from our downward sloping diagonal line of reflection. Time for some practice now. So before we go any further, make sure you hit pause and try these questions for yourself before the answers come up. My recommendation to you is to start by counting the number of squares on these grids and set up the same size grids on your own squared paper. For example, this first question here is 8 squares high by 14 squares wide. So make yourself a rectangle of the same size. Make sure you put the mirror line where you see it on this grid, so 7 squares in from the right. And make sure you place your image in the same position as you see on this grid here. So 1 square down from the top, 3 squares in from the right, and you can see it's 1 square away from the mirror line. Go ahead and hit pause and do that now, and the answers will come up in just a second. I hope you took a moment to hit pause and do that for yourself, because here come your answers. For our first example here, I hope you started by drawing that grid. And as we saw, our image was 1 square away from the mirror line, so its reflection is 1 square away from the mirror line. If you drew that rectangular grid to begin with, it may help to see that your new reflected shape is 3 squares away from the side of the rectangle, 1 square down from the top of the rectangle, and 4 squares up from the bottom of the rectangle. For the second image, we start by drawing the rectangle, which is 8 squares high by 10 squares across. You drew your mirror line right through the middle there, 4 squares down from the top, and the image. And as we can see, that image was touching the mirror line, so its reflection is also touching the mirror line. For our last image, we drawn a rectangle, which was 10 squares across and 6 squares up. And our mirror line's right there in the middle, 5 squares across from the right, 5 squares across from the left. And our reflected image was 2 squares away from the mirror line. And you can see that it's 1 square away from the left-hand side of the grid, 1 square up from the bottom of the grid, 1 square down from the top of the grid. And this point here is 4 squares away from that mirror line. This point here is 2 squares away from that mirror line. Let's move on to the second part of our practice exercise now. For this section, you need to set up your own set of axes. Make sure you use the same scale as I've used, so count the number of squares. Here I'm using 2 squares for every 2. Make sure that your x and y axis will cross at 0, and make sure you place your mirror line and your image in the correct positions. Here my mirror line is 1 square to the left of the y-axis. You may want to work out what the equation of that line is. Go ahead and hit pause now so you can draw these axes, copy these images, plot the mirror lines, and draw your reflections. I hope you had a chance to hit pause because here come your answers. So for this first question here, I hope this isn't what you did because you would have reflected in the wrong mirror line. Our mirror line is the line x equals -1. And as you can see, this coordinate point here is 2 squares away from that mirror line. So its reflected point would be 2 squares away from that mirror line. Same thing with this point down here. 2 squares away from the mirror line, I reflect it 2 squares away on the other side of the mirror line. Join those points up, and this should be your correct reflection. Just check that you've plotted that correctly by checking the coordinates. This here is the point -3, 2. This is the point -3, 5. This is the point -4, 5. And this is the point -5, 1. For the next example, we're asked to reflect in the y-axis. Hopefully you all know what the y-axis looks like. It's actually labeled with a y. There's my y-axis. Measure the distance to the y-axis and plot your point the same distance on the opposite side. I hope you didn't do this. That's translation, not a reflection. Let's see what we did wrong here. I measured the distance of this point to the mirror line. It was 2 squares away, so I plotted the point 2 squares away. So far, so good. I measured the distance of this point from the mirror line, and it was 4 squares away from the mirror line, so I plotted a point 4 squares away. So what have I done wrong here then? The problem is I got impatient. I didn't plot all 3 of these points. This point here is 4 squares away from the mirror line. So plotting that 4 squares away on the opposite side gives me this point here. So there's my correct reflection in the y-axis. Next, I'm reflecting this triangle A in the x-axis. I hope we all know what the x-axis looks like. It's labeled with an X. There's my x-axis. Again, measure the distance of each of the coordinates to the mirror line. I hope you didn't do that again. It's not a reflection, that's a translation again. Again, let's go point by point. This top point here was 1 square away from the mirror line, so I put it 1 square away from the mirror line. This point down here was 4 squares away from the mirror line, so I plotted it 4 squares away from the mirror line. Again, it looks good. However, this point down here is 4 squares below the mirror line, so it should be plotted 4 squares above the mirror line. Join those up, and that's our correct reflection of triangle A in the x-axis. And finally, we need to reflect this shaded shape in the line with the equation x equals -1. So we had to start by drawing the line x equals -1. Is that a vertical line or a horizontal line? Remember, x is -1. Here's my x-axis. Here's where x is equal to -1. There's my line x equals -1. And reflecting in that line, measuring the distance of each of those coordinate points from that line and measuring the same distance on the opposite side. I hope you didn't do that. What did I do wrong here? That's a reflection in the y-axis. I want to reflect in the line x equals -1. So count the distance of each of the coordinates of the original image to the mirror line. This point here is 1 square away from the mirror line, so we'll plot it 1 square away on the other side. This point here is 1 square away from the mirror line, so I'll plot it 1 square away on the other side. And I continue that way, and I join it up. This is my correct reflection in the line x equals -1. On to the third and final part of our practice exercise. Here we want to describe our transformations. To make this easy on you, you know we've only been looking at reflections today, so all of these transformations are reflections. However, you also need to give the equation of the line of reflection. Again, hit pause so that you can try these questions on your own before I take up the answers. If you're copying these diagrams into your book, make sure you set up a scale with care and use the coordinate values to make sure you're copying it accurately. So go ahead and hit pause now, and the answers will come up in just a minute. I hope you had a chance to hit pause, because here come our answers. For this first question here, we know it's a reflection. But is it obvious where the line of reflection is? I think it probably will be, but if you struggle with this, try this trick. Plot the corresponding points and look at the distance between them. Find the midpoint of that distance and do that for all the corresponding points. So here's the midpoint between these 2 points. There's the midpoint between those 2 points. There's the midpoints between these 2 green points. And there's the midpoint between those 2 pink points. As you can see, these midpoints will line up to make a perfectly straight line. And that's our mirror line. What's the equation of this line then? Well, it's a horizontal line and it's crossing the y-axis at 0. So we could say that this is a reflection in the line y equals 0. Or you could simply say this is a reflection in the x-axis. For the next example, you can see again that it's a reflection. Is the line of reflection obvious to you? It might be, but again, if it's not, let's join together the corresponding points and find the midpoint of the distance between those points. And as you can see, all those midpoints line up to make a perfectly straight line again. What's the equation of this vertical line? It crosses the x-axis at 0, so that's the line x equals 0. Or you could say it's the y-axis. So B is reflected in the y-axis. Finally, for this last question, they tell us that triangle A is a reflection of triangle B. And it helps that they tell us that this is a reflection, because it's easy to confuse these types of reflections with rotations. But I assure you this is definitely not a rotation, and that'll become clear if we follow the steps to find the line of reflection. Like we did before, let's connect the corresponding points and find the midpoint of those distances, and we'll see that those midpoints all join up to make one straight line. We've got this straight upwards sloping diagonal line. Now, what's the equation of this upwards sloping diagonal line? Remember I told you before that they almost always give you the same diagonal lines, either y equals x or y equals negative x. Now to see which one it is, we can see that it's upward sloping, but you might want to look at the coordinates as well. We see one of these coordinates is the point -1, -1. Another point was the point 0, 0. Another point was a bit difficult for us to see, but we can look at some other points along this line. This point here, for example, is 1, 1. This is 2, 2, 3, 3, 4, 4. You should see a rule clearly forming here. The y coordinate values are equal to the x coordinate values. So the equation of this line is simply y equals x. Now that brings us to the end of this lesson. I hope you found this helpful. Please feel free to leave me a comment if there's anything that I left a little unclear, or if you've come across a question that you find a little bit more challenging that you'd like me to have a look at with you. Otherwise, till next time, definitely keep practicing. It's fairly straightforward, but it's easy to make mistakes. So practice, 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 and I know you'll get it.